So welcome to the live video. So basically there is a vertex cover problem I have to solve it using greedy approach. So I think you pretty much know about this stuff of problem where I have an undirected graph and I have to use a greedy approach to get the vertex covered. I mean the minimum vertex covered, having that sort of covering every node. So for this, if I take 0, then 1 2 is done. If I take 1, then 3 is done. Then if I take 3, 4 is done. If I take 5, 6 is done, like this. 5 6, I mean I have to take just 2 node and stuff. So okay, let's proceed on the journey. So basically what's my approach is, basically I have to create a test. I can change the name also. That will be something sort of blank set, and I have to. So let's say this is my graph. What I have, undirected graph, something like that, and I have to take. I have to create a, let's say, dummy set, and in the dummy set, I should put the all edges. I mean something. Let's say A, let's say B, not like that, but this A will be denoted. Let's say this is U, this is B, so this A should be denoted like U and V, something like that, U and V. So I have to uh, store all edges here. There should be all edges, and then I have to do what actually. Let's say this is dummy. So when my dummy is not empty, so why my dummy is not empty, that time I have to do what? I have to do one thing. I have to do one thing at first. So first thing I have to see that if that what to do, I have to take at first a random vertices. I have to take a random vertices or an arbitrary vertices, and I have to check that. Let's say I have taken U. Let's say I have taken U, and U is connected with V. So I have to what it say, I have to erase the all edges, I mean adjacent edges already been present, already been connected as the sort of incident to this. So I have to delete V and U from my edges array, like that, and I have to put U in my test array, something like that, and after that, yes, I have to return the test. So this is the basic concepts. You can find it out on, maybe, yes, you can find it out in the Geeks for Geeks algo. This is pretty coolly, they have initialized the whole stuff. And yes, I have found that stuff from here, and this is basically there is a saying that initialize the result and 0, and that's the basic concept. So I will create, and I will generate a fully fledged code in C++ that will give me the vertex cover problem. So let us do it. This is a simple greedy approach. So that can be done using greedy, using, there's a stuff called uh, age hierarchy or something. There's a spelling or misspelling maybe, or vertices, something sort of problem, but greedy is most popular and most interesting. So let's do it. This is the vertices. I could create some sort of, I have to create a list of integers for adjacent. Okay. Then a public access modifier. They will have, I have graph construct. I've created a constructor because the constructor I should get the same name. So graph, it will get int the vertices, and let's say void add. Just have to add the edge. Int, let me ends. So what I want actually, that will connect it on there. Okay, I've connected it to what I have to do. I create something sort of, let's say, um, this is connected to, so let's remove int, it's equal to v and u, then have age like vw, like what this, let's say this is an age, v is like with w, something sort of something like that. Then I'm going to print void vertex over, that will print sort of vertex over. Then let's so we'll take the int vertex and we'll do nothing but we'll create a this class. So this v equals to v, and adjacent is generally the new adjacent, new keyword list v. So that's as simple as that. Now what I have to do, now I have to create that stuff for each. Creating age is pretty sure you how to do it. So this is my blank, not like this, maybe this, and I have to do something sort of push back. So w, so if I have v I will do w, if I have w I will do v, as simple as that. This is pretty simple. So that will return, it will return, it will return, let us see if we want that is then I have to do what, adjacent v, adjacent of v dot push, so it will push back stuff from w, is this execution product, and then I have push back. So adjacent v dot push w, and same wise adjacent w push back v, because the graph is undirected. Because the graph is undirected, there is no sort of some direction. Pretty cool. Now this one, I have done this, I have done this, I have to do this. So it doesn't return. So yes, let me see. So print doesn't take anything, so I have to do just default graph and vertex. But it will not take anyone. It will say what it will have, how it will print. So basically what I want, so this is my normal graph. Once my pointer is on here, I will create a flag. Let's say it can be a integer. If I have integer, that will increment, but I don't need this value, so let's take it as a boolean value. So if it is visited, let's make it false, and then it will be true, then it will be true, and it will be false. Okay, I think I got it. So bool visited the vertices, then let's have a for loop. Int zero, I should be less than the vertices, and I will increment it simultaneously, and I have something also like that. Yep. Now what I've said, that once this is visited, this will be false. So yes, visited of I equals to false. As simple as that. Then I have to create a iterator that will iterate something. So let's proceed. So list is int, then iterator I will start actually from, let's say this is u, this is v, it will start this something like that. So yes, I think this is in a loop. So for equal to 0, then u should be less than capital V. Is this true? Then it will go true. Okay, got it. U plus plus. Hmm. So this should be picked when I have done with my u and done with my v. If only done with my u, I don't done with my v, I cannot take it. I mean, I cannot visit it actually. Okay, so let's implement that logic here. If the visited of u is false, if this is done, then I have to go through the all adjacents that is connected with u. Let's say this is x, this is y, all adjacent. Okay, so I have to do so. Is there any easy way to do it? Let me calculate. Okay, okay. It will do it. If for I equals to adjacent of u dot begin I is not equal to adjacent of u dot end and a pre-increment operator and int v equals to and if the simplest stuff v is input false as simple as that, then the visitor of v will be true, visitor of e will be true if I mean the both server visited. So if this is only visited, then I will apply that sort of logic, and if both are visited, so visited of u equals to true, okay? And obviously we can't break. Then it's after this for and I should be less than capital V and plus plus. I think I have a parenthesis. Let us check. Then if visited of I, then if visited of I, then just print I something like that. Yes, I have a bug that should be here. Yes, I think there is. Then it will so the graph. Let's name it as G. Then let's look at the size of the graph and the vertices. G dot voltage. What I have 0 1 0 2. Got it. 0 1 0. So actually my light is a bit of fluctuating that way. And G dot add H. I have 1 3 3 4 1 3 3 4. What else? 1 2 3 4 4 5 5 6. Dot add 4 5 0 5 6 and then G dot print vertex cover and is return 0. Yep, as simple as that. Let me just do run g++ vertex. Is there an error? Is there an error? Uh, it's saying list does not name a type. So what does it mean? Okay. So we um, vertex. I have done a big mistake, so I have not included the namespace. So using namespace. Let me know. What does it mean? Remember a function uh, error redeclaration of iterator I. Let me see. Where was 33 till 34? So we me insert when I've done a mistake. I think a full mistake. Got it. So let me, if this for loop is not for that, okay, got it. This for loop is just for this only. I know there is a mistake. Let me see. Yes, a.exe. Yes, got it. So this is the output, and let me discuss about that output. So yes, so if I take 0, if I take 0, 2 and 1 is done. So 0 is the first. So 0 is the first. So 0 is the first. Next, if I take 1, I had not take. If I take 1, 3 and 4 is done. I mean, if I have to take 0 and 1 actually. I have to take 0 and 1. So firstly, I have to take 0 and 1. 0 and 1. Then I take 3 and 4. Then I take 4 and 5. Sorry, my 5 and 6 and done. This is the answer. And this is how it works, and you can find it out on my GitHub. I have just posted in GitHub. So thank you guys for watching this video. See you next time.